Um, the first question, you can do it with no work. It is pre-cal, though asking honors pre-cal. All of them got it wrong. Asher, what do you think?
Wait, we're going to do number one or
Well, number one, just real quick. Like, it should be quick.
-2.
-2. Why is it -2?
Because you can just factor, like, multiply them together, and then they both have biggest powers x squared, so -2x squared over x squared.
Okay, so you just said if you were, like, the limit as x goes to infinity, you want to find the coefficient of the largest powers anywhere. So Asher said we could just simplify it and just look at -2x squared on the top and positive x squared on the bottom, -2. Yes. Pre-cal? I did not do that. I was like, come on, guys, it's just pre-cal. And I'm going, okay. But try number 3. One of the most missed.
Is that F5?
That says F equals, and then what is F?
Yeah, product and chain rule.
Yeah.
Anyone have an answer yet? Isaiah, how do I start? Okay.
So obviously it's changed. So you do the derivative of x squared plus 2x.
So the,
And then you power, so you get 3 on the outside, so it becomes 6x.
okay. Kind of concerned about some order of operations here. So it is the first term left alone, and then all the stuff you're saying, which is what?
6x, 2x plus 2 squared.
Okay. Multiply by the power, lower the power, and then multiply by the derivative of the stuff inside. Okay. So you combine things already.
X squared.
So multiply the power 3 down here, leaves it as squared, and then that x squared plus 2, doing the chain rule, we get 2x. And now the other part of the product rule. Yeah, we were doing product rule.
Yeah.
First times the derivative of the second, and then second times the derivative of the first, which is 1. So I don't get any of these answers.
Yeah.
So this is algebra now. Natalie, what do you suggest we do?
Ugh, it's really irritating, the stupid novel. You have to factor out the x squared plus 2, because it's a common term there, so you'll take out x squared plus 2 to the second power. And then it's x minus 1, both just the 6x here, plus x squared plus 2, and then once you that deal with that and combine like terms and all that, I think you get D.
Am I right about that? Okay, Sam, how do we get where? Asher, was that you? Okay, are we okay with step one where Isaiah did product rule with a whole bunch of chain rule in it? Okay. So then Natalie said, well, that none of these look like that. Maybe we need to factor out the common term. There was an x squared plus 2 of them in this first term, 3 of them in the second term. So the thing in common was taking the 2 out. What was left behind? Well, x minus 1 was still there, and the 3 times the 2x was still there. And those guys were multiplied together. This had one thing left in it, still one more x squared plus 2. Got to distribute these. 6x squared minus 6x plus x squared plus 2. 6 plus 1 is 7, x squared. Whew. So then, in the end, it looks like D.
Yeah.
Okay, so I did a very similar problem with BC Calc today. Theirs was actually easier. It gave them the derivative already, and they had to factor. They had to do something similar to this. They are going to get you guys at making you do algebra and arithmetic very carefully. And you guys are messy. You're just messy. You don't read your own handwriting. You lose negative signs. You transpose numbers. So you have the math skills. You don't have the neatness organization skills. That's the concern. So number 3 was one of the big ones. You guys okay with this? And I don't remember my other numbers. 5.
To 0.
Let people think about it first. 3 of you have the answer already, but some of you going, nah, good. I mean, clearly plugging in 0, we get 0 over 0. Can't do that. So this is chapter 2. What was, there's a couple of things we could have done. Morgan, what are you suggesting we maybe do?
We factor out the x squared, right?
Okay, if I factor out x squared out of the top and bottom, what's left up top?
5x squared plus 8.
And on the bottom?
3x squared minus 16.
Okay, so x squared over x squared goes away. Landon, can I plug in the 0 now?
Yeah, you can.
And what do I get?
1/2 or negative 1/2.
Noah?
So, when would you use L'Hopital's or whatever? How would
Okay.
you know?
You could have done L'Hopital's with this. It's a pain though. It's much faster to factor out the x squared and reduce them. You can do L'Hopital's. It's more difficult on the arithmetic and time.
So you just have to see something like that you'd be able to do.
Okay. With all of these questions, there's the I just see the fast way. There's often a number of ways to go. And if what you saw was 0 over 0, you're right, that's where L'Hopital's applies. And I can do the derivative a couple of times. But that's the hard way to go. Yeah, so at this point, it's teaching speed. And no, it might be better if you're not on your phone.
That's a lot of work.
It is a lot of words, a lot of options. Yeah. Okay.
So in order to find if there is a limit at x equals 2, you have to plug into both of them. Well, you don't have to plug into the second one, it's just one. But you plug it into the first one, and you get 2 squared minus 4, which is 0, over 2 minus 2 is 0. Oh, wait. Oh, you do Loki Talks, right?
I'm gonna do it this way.
Oh, yeah, you could just factor it out. Sorry. Yeah. So then you just have x plus 2. So what? So that, yeah,
No, it doesn't know.
that doesn't work. Oh, yeah, and I completely know what I did. Sorry.
Okay, guys, first thing, as we go close to 2, the limit from the left, the limit from the right, that's this equation. So the limit as x approaches 2. Can I plug 2 in? I get 0 divided by 0. I get the problem I had a second ago. I could do L'Hopital's, or I could do Algebra 2, or pre-calc, or both. Factor the top and the bottom. That problem factor goes away. Plug in 2 to the leftovers, I get 4. The function itself is defined as 1. Does the limit exist? Yeah. This was a hole where the bridge washed downstream, so the limit exists. And Anya, what were you going to say?
I was going to continue.
Okay, so is it continuous?
No, it's not. Therefore, it can't be differentiable with it. So it's just
Perfect. Okay, so this, that the y value did not go to the same place, there's a hole. It's not continuous. And Ananya says because it's not continuous, it's not differentiable either. So the only one that's true, 1 ohm.
Tell if it's differentiable. Like, what does that mean? You need
Okay.
to find the slope.
So right here, she said because it's not continuous, it cannot be differentiable. Well, if I said, I'm changing the problem, that's now 4, it is now continuous. All right. Is it differentiable? Well, that
Maybe it depends on the stupid corner is.
maybe it depends on the stupid corner. Okay. Harsh, rude, mean, gosh.
Alright. What's bad? Try meditation spell corners.
Okay. So that function up there is going to behave like x plus 2. What is the derivative of x plus 2? 1. And I changed this problem now. What's the derivative of 4?
Here.
I don't know that this works that way, but what's the slope? Like, it's not going to be, the slopes would have to be the same,
Alright.
and it's not. Okay. So those most missed ones, 3, 5, 6. And 13. What? Why did it do this? You can do this a couple of ways. Asher, what's your suggestion of ways to do it?
What I did, I just put in ln x for x and then did chain rule for the first one. Just kept it.
So you did this?
Yeah.
So he said, well, I just plugged ln x in for x and then did the derivative of this. What is, that seems gross, but what is the derivative of that?
So the first one is 2 ln x over x.
Because multiply by the power, lower the power, leave it alone, and then multiply by the derivative of natural log of x, which is 1 over x, okay?
Plus 2 over x.
Does anyone else have a different way of doing it? Okay, well, if I didn't know what f was, the derivative of this is f prime of, leave that alone, times the derivative of the stuff inside. Iris, what is the derivative of f of x? 2x plus 2. So does this work that f prime of ln x, okay, so plugging in f prime of ln x is 2 ln x plus 2 all divided by x. Do I get the same answer? They look a little different, but are they the same? So which one is it? A? Okay. Honestly, that's my problem. I can't pick the right one out of the lineup. I get them right, and I don't pick them.
So you can just divide the same denominator, right? So it's
Common denominator, so this is 2 natural log of x plus 2 all over x, which is the answer we got here. So options, whichever one makes the most sense to you, whichever one seems easiest, they both give you the same correct answer in the end. Right, Sam? All right, 14. Woot woot. Try it. Love the confidence. You think you got it?
Never mind, that's easy, yeah.
Oh, Sheen's not here. Indy's not here. Keith is not here. Where is everybody today? Eric is not here. Francis is here. All right, what do you think? Yep.
We know that the second derivative proves that f has an inflection point when it hits and crosses 0. And we know that in order to get from 5 to negative 7, it has to cross 0 at some point. So if t
So you said inflection points are where the second derivative changes sign
Yeah.
and had to hit 0 or be undefined. And so you're saying from here, it hit 0, it went from positive, second derivative went from positive to negative. There had to have been an inflection point in there somewhere.
Yeah, I mean, and even if it doesn't cross that 0 at x equals 1, it still has to cross at another point to get the positive.
So maybe it touched down, bounced up, but still, okay.
That's why it wouldn't be b.
Okay, well let's reason through this. Given that information in the table, what has to be true? Does it mean that it's increasing over 0 to 2? I mean, telling you the second derivative, the first derivative could be doing anything. And it like the first two, same reason. It like you don't know anything about it. Does it have a local maximum at x equals 1? It might. Probably not, but it might. And he said, didn't have to be right at 1 that the inflection point was, but you know that it had to be in there somewhere. And so it had to have changed concavity somewhere in that window of time because the second derivative changed time in that interval. Sydney?
Can you explain why it's not D?
Why it's not D?
Yeah.
Kian said maybe like if this is the second derivative 0 to 2, the second derivative, the second derivative was 5, then maybe at 1 it hit 0, but it didn't actually change, it just took a pause, and it was still concave up. But it did go negative eventually. It went from positive 5, second derivative went from positive 5 to here. So maybe it was 1.7 where the inflection point was. Maybe it bounced and went back up, but it had to, he said it had to have changed at some point. This is where they're going to, this is how they ask definitions. They'll come up with examples that are really irritating and fine point. Do you remember that little catch? Noah, nothing? Okay, the dreaded implicit differentiation, chain rule, and trig. Oh yeah.
Everyone's
Love
face.
this.
I know.
And these being multiplied. Like sine x plus.
It's sine of x times y. It's not sine times x y. You got the answer? Did you
Yeah.
already?
Wait,
Why I did yes.
Right.
slow down.
Because you might be the only, well, there's 4 of you that consistently, you're like, yeah, I got that already. The 4 of you gotta wait for the other 20. And a reminder, if you have not done the delta math, the quick problems that wasn't so quick, those are due tomorrow. And I am putting in the percentage score that you got. The medium ones are open. A few of you are already done that one as well. Yeah, you don't get all or nothing. It's if you did 80% of it, you get an 8 out of 10.
You did 80%.
Oh, it's 10 points.
If you did 80% of the quick assignment.
Oh, why would you not just finish the whole thing?
Good question.
We forget about it sometimes.
I ask that question daily. Well, if I don't know how y'all think, but
Why not just finish the whole test?
Noah,
Is it due tomorrow morning?
do tomorrow at 8 a.m.
Just get the
And you guys were given time in class to do it, and some of you still left this class with 0% done, which meant you were doing something else. Your choice, bad choice, and it was your choice. Jackson, how do I start the problem?
I started this one by doing like the derivatives.
Okay.
So on the left it would be cosine xy, and then you have to like chain rule it. So then it's you multiply it, but then inside of like that you have to do product rule, or
Okay.
Yeah.
So what's the
So-
derivative of x times y?
it's y plus x times dy dx. And then the other side equals 1.
Okay. All right. So what is the answer? I need to get dy dx itself.
Oh, the answer?
Okay, wait. Okay, hold on.
I didn't see that.
So you got to do the whole equation. So Jackson said that, and then the derivative of the other side. So Jackson, can I immediately say, what do I got to do?
So I distributed the cosine xy. And then I subtracted by y cosine xy. And then,
I think it's D.
or subtracted. And then divided by x cosine xy.
So we want 1 minus y times, so not. The anog. Lots and lots and lots of places to make simple, careless mistakes. So they're coming at you guys because you don't have to suffer through chapter 9. They're going to make you suffer with algebra and arithmetic and do like 5 steps to do a simple multiple choice question. So do you guys understand the format of the test? Have you looked at things at all?
I did the homework. Multiple choice.
The multiple choice without calculator is 30 problems, and you have 1 hour to do it. And it is scaled up to be 36 points. I'll explain that in a second. Multiple choice with calculator is 15 problems. You have 45 minutes, and it goes in the grade book eventually as an 18. These guys add up to 54. Free response, there's 6 of them, 9 points each. It is also 54 points, so the total test is 108. And I think if you get like about 60 out of 108 of the points, you get a 5. Yeah. Free responses gauges as about 15 points or 15 minutes per question. And some of you, like some of those questions, yes, it's a long test. It's 3 hours and 15 minutes of seat time. Yeah.
For the FRQs, is it like they give you a certain amount of time for like questions 1 and 2, or is it just like you have like 2 hours to do 6 questions?
We'll separate it up.
So question 1 and 2, here's 30 minutes, you have your calculator, go. After 30 minutes, you need to put your calculator away, and you can open the other 4 questions, and you can work on 1 through 6 at anything you want. You can go back to questions 1 and 2.
Okay.
You just can't go back to the calculator. But that said, a lot of 1 and 2, sometimes it's set it up but don't evaluate it. Or even if it says evaluate, you can at least, like if you remember, oh yeah, I got to do this, you can do the setup and you'll get a point or maybe 2 for setting up the integral. And if you needed the calculator to do it, all right, you might not get that point because you already had to put the calculator away. But you might be able to go back and do something. Okay? And all of these assignments are already in the grade book. Please warn your parents that the things in there say raw score and parentheses not for grading, because not being mean or anything, they're all going to be E's. And if you don't get an E, like that's like rolling in it, you're solidly in 5 territory. So before the curve, it's kind of dismal. Okay. So 3 and 4 are already in there. You guys already did them. You saw number 3 was dismal, but number 4 was like, some of you got like a letter, not E. Woot. Morgan's like, rah. Just the look on your face was like, okay. That was 16. All right. 18.
Is it like
All weekend.
is it like the rate of change?
I have to work.
I don't know, I'm gonna let you do this one.
No. Fight through it. What does it mean this line is tangent to that guy?
It's touching, that is your point.
Okay, when they are tangent, what has to be
They
true?
have the same slope.
Slow.
Oh my goodness, they have the same slope. What is the slope of this guy? What is the slope of that guy?
Oh, I figured it out.
Fight through it. Read the words. What do they mean? You know this.
Set it why you
I guess so.
just. That's how it's.
That means parallel?
Just solve for K. How do you solve for
So because it said it's tangent, it doesn't just touch there, but it means the slopes had to be equal there. Carson, how do I find the slope of the quadratic?
Do normal power rule, so 2x plus 3.
Okay. What's the slope of that guy? Jacob, what's the slope of the line?
2.
Wait, what?
What? Oh, 1. Negative 1.
Okay. Carson, why are you giving it the stink eye?
Wait, do you keep the K in there as a constant? That's it.
Okay, well,
Plus K.
I-
So,
I was just doing the first thing. Sam said because it's their tangent, it means their slopes are equal. So Carson found the equation for slope here. Jacob found the actual slope. Jackson?
Isn't if K is a constant, that means that like when you take the derivative, like there's no derivative, right? Like it would be 0.
Derivative of k went away. Yes.
Right. Okay.
So I'm using geometry. Like the number in front of the x of that linear equation is the slope. Or dy dx equals -1.
-1 is pretty good, yeah.
So because it was tangent there, these slopes need to be equal, right?
Yeah. -2.
So Ananya, what is x?
it's not. What is the value of Yeah.
Well, would you then plug that into the x squared plus y to get y, and then plug that both into.
Okay, so we have one step closer to figuring out what k is. Will says, do we now take this -2 and plug it back in there? Absolutely. Find the y value. Y equals -2 squared plus 3 times -2 plus 1 to get
Negative. Big group 1.
and holy crap, we're still not done.
Then we plug in the x and the y.
So x plus y equals k. So here's the difference between A, B, and B, C. A, B, these are the most missed questions, and it's because there were so many steps. This is supposed to be multiple choices. They're supposed to be fast, and you guys need to do 3, 4, or even 5 steps to get the end answer. BC Calc, it's usually 1 or 2 steps, and they're difficult, but these are not easy. These are like, it's easy to make simple mistakes, and that's just rude. But whatever, that is what it is. So this is their way of making you sweat. 20 is the next one.
Are you going to be here Thursday?
Yeah.
That's what then.
Isn't it fast? Look at the temperature and not the answer.
Oh, when do we have points of inflection?
When f of x, when f prime of x crosses the x axis.
Sign changes.
What's-
Sign
what's-
changes.
What sign of what changes?
F prime of x. Oh, no, when double prime of x.
I think that's D. Yeah, I'll get that.
Okay, it's when f double prime changes sign. So I need to find the zeros for f double prime. Sydney, what are the zeros for f double prime? Do I have to factor or is it done for me? Okay, so when is it 0?
When x equals 0, 3.
Where?
0, 3, and 6.
Okay, 0, 3, and 6. So number line, name it. 0, 3, 6. Logan, how do I fill out the number line?
You plug numbers in between them back in.
Okay, so like -10. Do I get positive or negative? What do I get?
Well, let's do it like that. I just said that it was 3 and 6, that's it equals 0.
You said what?
That it was 3 and 6, since it equals 0 at 3 and 6.
But it equals 0 at 0 too.
I just like,
You just ignored that. So then you might have just been lucky. Noah?
You plug in -1, then you get a negative value because -1 minus 3 is negative.
You get a negative times a negative times a negative squared, which ends up being 4 negatives, which is overall positive. Plugging in 2, that's positive. This one's negative, and that one's negative. It's still positive. So not a critical point, and you were lucky because you just ignored it. Plugging in 5, the squared is never going to be negative, so I'm not going to bother. Plugging in 5, positive times negative. Plugging in like 100, positive times positive. Sign changed for the double derivative. Sign changed for the double derivative, so it is 3 and 6 only. Okay.
One out of 50.
Okay, this one. The graph of the particle's position is shown above. So position. The graph has horizontal tangents at 1 and 5, and a point of inflection at 2. Where is the velocity of the particle increasing?
Because it's accelerating.
Oh, is that what it means? Where is the velocity increasing? So is it asking where is acceleration positive? Kian?
Yeah, the velocity is increasing when the acceleration is positive. And the acceleration is positive when the graph is concave up. And the graph is concave up from 0 to 2. So it's like,
Okay.
I think that's right.
Say it again slower.
I got this. The velocity is increasing when the acceleration is positive.
Velocity is increasing when acceleration is positive. So that is also saying if this was -2 miles per hour to -1 mile per hour, you are technically increasing because you are less negative. And then to 0 miles per hour, and then you're moving in the positive direction. So he's saying the velocity is not absolute value. The velocity is increasing when acceleration is positive. How do I read acceleration? Concavity. And so it's concave up on position, concave up when it makes a cup, 0 to 2. That's why they told you the inflection point was at 2.
How do you know it's not 2?
They had to tell you the inflection point was there. That's when concavity changes.
So like in this kind of question, will they always tell you like the inflection point or give you the tools to find it?
Yeah, and they can give you extras. Did we need to know about the horizontal tangents? They were like, no, don't add them in there so you know, you gotta know what you're doing. Like, are you gonna choose where velocity, the slope of this, where velocity is positive, or are you gonna choose where acceleration is positive?
Is velocity increasing when velocity is positive?
When acceleration is positive. So I don't like,
Position's increasing when velocity is positive. Velocity is increasing when acceleration.
yeah. So it all matters, like, are you talking about position, are you talking about distance from the origin or where you started? Yeah. Hang on, there's 21, 23, there's two more that are stinkers.
Oh, this is the split.
Initial value problems. What do you have to do first? Y's with y's, x's with x's?
Yeah.
Sam, how do we do this step?
We have to, it starts with an I, implicit differentiation.
This isn't implicit.
Or, that's just Y and.
Integrate. Raise the power, divide by the new power.
And then 1/3 X.
Raise the power, divide by the new power.
Plus
And-
A, C.
Randomly, you add plus C. How come I only added plus C to one side, Josh?
You only need one side.
Because random unknown stuff here got swept onto the other side.
Why? Is that when you plug in for X? Or
So
other way? Why is it written?
think of it this way. Y equals the -2, so the other guy's the X.
And then you plug in, define C.
So -2 squared.
It's just 2 equals 3 plus C.
25.
So I don't get the answer still.
Wait, so
I don't like.
oh,
3 squared and not 3.
So what's the answer?
We have to
Yeah,
multiply
you
both sides by 2
and then take square root.
Multiply both sides by 2, then take the square root. Gross.
One is negative, so you get the negative answer.
And then the square root, it's plus or minus that stuff. And we wanted the negative branch because that's where the initial value was. Noah?
I was just saying that's fine to like finish all multiple choice. That's one each one.
They give you an hour, that's plenty of time. But, so Noah, these were the top, let's see, 6, the top 11 most missed on here. So they are the ones that are gonna take more time. After?
You found 22.
Going with no. So, I didn't know this was in the AD curriculum, and I don't think it is now. This is an old exam.
Oh, I did not miss these problems.
It came out
Any of you in environmental science? Population max carrying capacity, population growth.
Yeah.
So M here is the max carrying capacity. The population, as it gets closer to the max carrying capacity, it starts to level off. That's what this kind of problem is. I believe it is not in AD anymore.
It was like,
So,
it looks like something from the
No, I
SAT.
did not this one.
It looks like something from the SAT.
That was an in bio.
stop.